Good morning, good afternoon, good evening, and welcome to a post on movie science. If you like movies and you like science, this is the post for you. In the movie Interstellar, the Earth has become uninhabitable due to mankind's profligate ways. But instead of trying to fix it, scientists plan to transport a seed population through a wormhole to a new planet where humanity can start again. The story hangs on the existence of black holes and strange scenarios in which time passes quickly for one group, but slowly for another. When the groups meet up again, they are different ages. Meanwhile, the hero ends up stuck in the center of the black hole, where he becomes a godlike ghost, capable of observing any time or place and manipulating the objects within it. Thank you, Kip Thorne. You gave us an implausible gravitational wave experiment and an implausible science fiction tale. If you actually understand how relativity is applied in the real world, this entire plot falls apart. And if you think that my statements are not backed up, I encourage you to click on the blog link below. There are articles there about why the gravitational wave experiment is implausible and why Kip Thorne's movie applies relativity in a ridiculous way that is not consistent with the sort of scientific work that real scientists do, like in accelerator physics. When a real scientist sees a picture of the movie of this gargantua black hole from the movie Interstellar, he might say, is this the cover of a science magazine article, or is this the cover of a movie? And because of the way science is conducted today, it's often hard to tell. That's rather sad. It is hard to blame Kip Thorne for trying his hand at science fiction after Carl Sagan had so much success with the movie Contact. Then again, unlike Kip, Carl didn't win a Nobel Prize for his shenanigans. In Contact, Jodie Foster plays an astronomer who receives a strange signal from deep space. After using the help of a blind man to decode the signal, she discovers schematics for a gigantic physics experiment which is built in record time. A person is supposed to sit in the middle of the experiment, and it is believed that they will be transported to an alien planet, because what else could the machine be used for? They weren't allowing themselves to speculate that widely. A mysterious genius physicist watches all of this happen from a space station, and the viewer is left with the suspicion that he engineered this as a hoax, and that Dr. Foster, or Jodie Foster, didn't travel to a distant planet to meet aliens. She just got a bit of brain damage from the intense electromagnetic fields that the machine created around her. Good times. This movie did inspire a few thoughts that were about the effects of Wi-Fi and MRI machines on human test subjects, and I wrote an article about that because I was curious. So maybe all of this science propaganda does have some purpose. What are we supposed to take away from this? Science as a hero, science as a villain. In the movies Honey, I Shrunk the Kids and Ant-Man, the space inside and between atoms is shrunk down in perfect proportion. Given the sort of magical thinking encouraged by modern quantum mechanics education, this plot line is quite a natural outcome. Because if you use a naive interpretation of quantum mechanics, you might very well come to the conclusion that coherent light can cancel out incoherent vibrations filling space. I think that we are inherently out of sync with everything in space, and that we can't predict what it's going to do, so it's always going to be incoherent. In the movie Cloverfield, a group of brave scientists tries to use a particle accelerator to drive a zero-point energy oscillation, which could be used as an infinite energy source. To do this, they needed to blast their way down past the viscosity of space itself, to the Higgs. And I imagine this as like pushing a trampoline down as far as possible, so that it springs back and vibrates in a way that allows for the efficient extraction of energy from it. But when they did this in the movie Cloverfield, they accidentally blasted through the trampoline and switched places with their experiment in a sort of anti-Earth dimension. The idea was that the solar system is like an atom, and Earth and anti-Earth are like spin up and spin down electrons orbiting around the sun. Their simultaneous existence is necessary for the stability of the solar system, but they can't directly see one another because light from Earth interferes destructively with the light from anti-Earth and vice versa. So they blast their way through the trampoline, flip into the anti-Earth dimension, see that their fates are slightly different in that dimension, and then they blast their way back to their home dimension. The paradox is that there was a difference between the two dimensions. Physics says that shouldn't happen. In the trampoline analogy, dimension A bounces, dimension B bounces, and neither notices that the other dimension exists. If dimension A decides to double bounce and dimension B doesn't make an equal and opposite decision, all hell would break loose in the physical world unless dimension B decides to quickly respond with a double bounce which compensates for the energy which has just shot into or out of the dimension. Net flows of energy from one dimension into another would be risky to play with. Now, I recently wrote a novel which involves communication between dimensions, and with people losing their minds due to confusion about which of their lives is real. But I didn't allow for a persistent energy transfer between dimensions. That would lead to one dimension feeding off of another, snapping back in a fabulously catastrophic fashion, fictionally speaking. In a Cloverfield sequel, the next logical thing to happen would be the gradual ghostly visibility of the anti-Earth and communication between the two planets, perhaps. Back to Earth, I think the takeaways from this list of films and from my novel is that if you can make a science fiction movie about your theory, that pretty much guarantees that it isn't garbage. People are convinced that, and the other takeaway is that people are convinced that they are capable of rendering our planet uninhabitable. Now, I think this is also a bit silly because our planet's pretty tough, and we're just, we just have to figure out how to survive on it, to live with each other and make things nice and avoid people going crazy, which seems it's harder than you'd think. And a little thought that's been swirling around my mind lately is the necessity of maintaining strong, healthy minority groups. Because if the majority group goes crazy because their assumptions about reality get undermined in some way, let's say that the majority group believes that they're really smart, they think that they know everything, they think that everything about reality is explained by their theories, and then something comes along that just says, no, your institutions are all wrong, you're dumb, you've got to start over and rebuild your identity on some other mountain or some other basis. That can happen to a group, and they all, the majority group, if it loses its foundation, it's lost. What do I do? And that's when you need to have a strong, healthy minority group that says, we've known this all along. It's going to be okay. And I think this is true with men and women in a field. And I think it's true with different races. You could have one race that thinks it has everything figured out. And then when that house of cards comes tumbling down, you need to have another group that can say, it's okay. We knew you didn't have it figured out. So, sorry for going off topic. Thank you for watching. Until next time.